there. How would we answer the first half of this question? Grace, what would you have to do?
So the average rate of change would be delta y over delta x.
Mm-hmm.
So that would be 306.25 minus 156.25 over 70 minus 50.
And what did you get that to come out to be?
It would be 7.5 feet per mile per hour.
Yeah, now if we did this one, this numerator's not right. This should be 306.25 minus 156.25. But the answer should come out to be 7.5. What would the units on that be, by the way? Now comes the tougher part of that. The second part is, what does this mean as it relates to braking distance? So you tell me, what does this answer signify? Because this one, and just so you're aware, these questions both showed up as 4 points on the Regents exam. So we're not going to sit here and pretend, oh, the Regents is so difficult that we can't possibly be successful. It's garbage and it's lazy. Looking at what's there, every one of you should have gotten the correct answer for A. Every one of us. The only one that's tough is the B part of this question, the second half. So what does this mean in context? Marissa D., what does this 7.5 feet per mile per hour, what does that mean? I think that would get you 1 out of the 2 points if you put something like that in sentence form down. I think so. Because I think it's missing one little bit more.
What I said was, as you increase your speed from 50 miles per hour to 70 miles per hour, each extra mile per hour you add to your speed requires an additional 7.5 feet of room.
Because the average rate of change is a rate. It's like per extra, what did you say it was, per what?
Per extra mile.
So every time, and I think you might even only get 1 though, because every mile per hour that I add, I have to add to my braking distance 7.5 feet, but he's missing one important distinction on there. So if I went through and said, what does the unit, explain what that rate means? If I wrote down, it means every mile per hour more that I go requires 7.5 feet more of braking distance. That would get me 3 out of 4 points. What gets me the 4th one? Do you know? Yeah, it's got to be. You've got to state that that applies. That rate only applies between 50 and 70. So between 50 and 70, each additional mile per hour of speed needs 7.5 feet more to stop the braking. Questions on that? All right. How many times have you seen that second question? A minimum of 2, because it was on, remember there was the quiz that I gave you where I gave you 8 questions for homework and I gave you a quiz on 5? That was one of them, so you've seen it once on the homework exam and once on the quiz, and I think it was on a test as well. By the way, the point breakdown was 2 and 2. But if you didn't put that between 50 and 70 and quantified where the rate was coming from, that's 3 out of 4. It's, in my opinion, a travesty for you to not read or to miss a detail like that because you're not, you know the information. If you said the second half of this, each additional mile an hour needs 7.5 feet more to stop, that's fine, but that's 3 out of 4 because you've got to be able to give me what that rate is. Now, the second part of it is the B half. Solve the equation out and justify your answer. So what you need to go through, just grab a seat and get with us. We've got to go through and solve this out algebraically. What's this requiring us to go through and do? What would your first step be? Megan? I'm going to subtract x over to the other side. That's right. And what's your next step going to be after you subtract the x over to the other side? Ben? What's your next step after you go through and subtract the x over to the other side? If you subtract the x over from the other side, take a look at the original, subtract the x over, what's your next step?
Take the square root of both sides.
Close. You said something wrong there.
Or square both sides.
Square both sides. There you go. So we're going to subtract it over and square both sides. That's the first thing we would do. Thomas, what's the next thing you would do?
Subtract 2x and add 7 both sides.
Careful. What? Sorry. After you square it, what are you going to write out first?
Oh, okay, so 2x minus 7 equals x squared minus 10x plus 25.
And now, what type of equation do you have?
Okay.
And that means you're going to set it equals 0. So what do you do now?
Subtract x squared.
What's the new equation going to be?
0 equals x squared minus 12x plus 32.
What do we do now from here, John? What's it going to factor down to? So we're going to do this. Now, this person left one step off. And I always include this because I took the points off on the Regents exam, and they kept telling me, no, you don't have to do it. That's how intellectually dull some of our contemporaries can be. This next step, though, will be on all of your papers. What's the next step that you have to go through and do from here? And let's see if we can use big kid words to accurately state the mathematics that's going on. Connor, what do you say?
You said both factors equal 0.
Look at that. What a wonderful thing to do. Because this person went right down to here, and I argued with them that they were wrong. You need an x minus 8 equals 0, and an x minus 4 equals 0. That step needs to be on your paper. Now you're going to go through and check both of your answers. They checked and eliminated the 8, which, by the way, I love because the genius of the question is you're always going to get people who say things like, well, do we always reject the negative? Yes or no? No, you don't always reject the negative. That's number one. The second thing you've got to know is not only do we not always reject the negative, do we always keep the positive? Do we always keep both answers? Whatever. It doesn't matter. You need to check every answer individually. Don't stereotype them because they're not equal. They're not the same thing. Do you always get rid of the bigger answer? No, you have to check them individually. Now, this is a part where you're going to get, out of 4 points, you're only going to get 3. What needs to be on your paper to get that extra point? Because this right now gets 3 out of 4. Who can tell me what's missing from this? I'll give you a hint. It's also highlighted on the paper. Yes. Not necessarily. You could give it in set notation if that's what you're asking. You could. I don't take off for that. Yes. You have to show that one works and one doesn't. That's called justifying your answer. So if this isn't on your paper right now, pencil to paper, make it happen. Because it's going to get taken off on your exam as well. If there's an answer that doesn't work, justify it and show me why it doesn't work. I'm not just going to take your word and or some programmer from Texas Instruments. Show me the replacement in, work out the out, say this equals this or this doesn't equal this. Is that too much, do you think, for you to go through and do? Kirsten, do you think that's too much or no? You sure? What are you going to get from me on the Regents exam? Above a 90? That'd be good. Who here got above a 90 on the or on the Geo for each one? Oh my God! Just so you know, you were all in Enriched last year. We had one person get above a 90. Who got above an 80? Okay, great. So you're right in the middle there. But dear Lord, so help me. I told you, listen, and I'll tell this to you nicely. Am I a crotchety, old, mean, you know this? I made the mistake once in pre-calc last year saying I'm an old bat. Well, then they started coming in with all these pictures of me, like dressed as Batman with gray hair or something like that. Fine, you can call me whatever, I don't care less. You know what I want you to do? Score highly. That's it. Every single person in here, the lowest grade that you should be looking at, the lowest, is an 83. Do we know why 83 is our floor grade? Do we remember? What? Pre-calc is college credit then. Raise your hand if you'd like to go off to college credit, or to whatever school you're going to. It was 4 college credits. Thank you. They're like $100. It's ridiculously cheap. Worst case, and you know what you get to do? You get to college and then you say, oh, you know what? Instead of taking 5 classes, I get one semester I can only take 4. What can you do with the extra time? Slip in. I don't even care what you do with your lives. I hope you get out. Do something to get you out of your parents' basement. Invent an app where people take more dumb pictures of each other and send them back and forth. Even dumber. But that's it. I need you to be successful. Period. And it starts with the work that you do now. How many points do we think I should expect you to get out of these 8? 7 or 8. Period. 7 or 8. And we discussed this the other day. You think that the rounding fairy is dangerous. And don't get me wrong, she is. But there's someone that's even worse than the rounding fairy. His name is the blank question bear. And the blank question bear finds young boys and girls. They could be very nice people. He doesn't judge. But if they leave a question blank on the Regents exam, the rounding fairy can't help you anymore. You'll be walking through, maybe you'll be walking out to the building someday, you'll be leaving school. And up on the roof, you know who'll be waiting for you? The blank question bear. And he's going to get a hold of you. We may not see you again. Have you seen, like a grizzly bear, what they do to people when they get a hold of them? It's not pretty. One day, maybe you'll come, and he always lurks for some reason up high. Maybe you'll be walking out to, mom or dad's car after practice someday. Going out, and the mom will be there, or the slide the minivan door. Oh, honey, we have for dinner tonight. We made your favorite. We cooked it. I was jumping off the hood of the car, attacking you and dragging you away, and your mom will go, oh, I knew he should have filled that question in on that Regents exam. Otherwise, he'd be able to join us for dinner tonight. Can you imagine? Don't you like your family? Why would you leave a question blank? I mean, he's vicious. The rounding fairy, she might rough you up a little bit, but most people come back. I haven't had anybody come back after seeing that bear. And I know it's very awkward for me because you'll sit out here and you go, why is that child getting dragged away over by the woods behind the football field? Oh, question blank on the reach. And even the security guards, well, should have pulled it in. There's only so much we can do. Now, have your note packets out, please, and open. We left off on day 5. I need you to read question 29. Read the first question on 29 and sign into your calculators if you haven't already. And boy, we got a lot to do today. Read out first one on page 29 and get started on it. Let's look at what's there. Corey, how many points do we need in order to give out an exponential equation? Not 3. That's for a parabola. 2. Can you pull 2 points out of this data?
For 150,000.
So we need 2 coordinates.
Oh, 10 and 150,000.
Okay. Mm. And what's the other point then that you fill in? Wants to modify this just a little bit, okay? I'll say this, you can stick with something that looks like this, we just need to make one little bit of a modifier on it, you know? Why do you want to put, you could do 0 and 150 and then your other point will change too. Why do you want to put negative 10? So now what would the other point be?
0, 185.
Yeah, or you could alternately, and in the other classes, they did it out the way that it was getting proposed, where year 0 was 150,000, and then year 10 would be that. It's all about just where do you want to start. Go into your calculators right now, and let's model this. This is we're gonna give out a model, so go in right now, take this and plug it in as an exponential regression, and we need that regression. Sign into your calculators if you haven't already. So now once we do this, and let's say we're going to round it to the thousandth position. So Anthony, how many spots after the decimal is the thousandth position? 3, all right. Make sure we label our headers up top. A we'll say is a year. B we'll say is the population. What would we do to take our regression? Go, 4, 1. Now we're going to choose an exponential regression. Adjust our criteria. The X's are the years. Population's the Y. It'll store it. Terrific. So if we did this out, what would the exponential be? Philip, we round it to the thousandth position. Hang on, Y equals what? Give me the full equation. What'd you get as your regression? You can tell me what that regression is going to be to the thousandth position. Really? Amanda, do you have it? What do you got? By the way, this is a generic exponential model. What is the growth rate each year? Hands up, please, if you can tell me what the growth rate each year would be based on the model that you're looking at. 3 people? This, to me, shows you still don't know your models, and you're going to get the questions wrong. You should not be expecting to be successful. If you can't look at that right now, you tell me it's going to be growth. We know that. What is the yearly growth rate going to be? 3 people. 4. McKenna? 2.1%. What would you do, McKenna, to figure out the population in 25 years? There you go. So I'm going to evaluate this out to figure out y of 25. That means I'm plugging in 25, not that it is 25. Show the substitution in. What would the population be 25 years later? Nick, let us know when you get it.
I got 11,039.
And 39, you said? Okay. Is this what we got? Perfect. Do you have to show the substitution in? Yes. Absolutely. Questions on what we have there? All right. Next one up. Oh, this one's interesting. Go through right now, please, and read the second question. Start answering it. Sam, what are you going to do to start this question off? How can you solve for K? Okay, so 2,000 is equal to? All right, what are we going to do to solve for K? Mickey, what do you say? Nope. This is the exponential you're trying to get alone. Divide by 250, yep. So what do we get when we divide both sides by 250? What's that going to be? Who can tell me? 8. So we've got 8 is equal to e raised to the 1.5k power. What do we do now from here? Sean K., what happens next? You're right. I need you to improve your language on it. Let's put it in log form. Okay? Now, there's multiple ways that you can do this, by the way. What would as we put this in exponential form, it's in exponential form, as we put it in log form, we could write it out as log. Sean, what would the base be? What's the base on the expression? E, the number e, yep. And it's always equal to the exponent, so your exponent is 1.5k, and you're trying to solve for e to this power is going to equal 8. You could also write this another way. Who can tell me the other way we could write this? Seriously? 3 people? 4? Tommy? Natural log of 8. Yeah, that's the other way of doing it, because log with a base of e is the natural log. In any case, what could we do to solve this out? I'd even say this, that's not going to solve it out, it's going to get you a value. What can you do to solve this? Not yet. We can do this without the calculator right now. You're trying to solve for K. What's your next step going to be? Marissa T? Yeah. Get your K alone, divide both sides by 1.5. So that's gone. Go into the calculator now, control division, and type in natural log of 8 or log base e of 8. Depends on what you want to type in. It doesn't matter. Oh, I should be outraged. I'll let it slide for now. Oh, look at this. your intimidation. Now, see how you did it all in one step? Makes it less writing for you. What is this answer going to be? Let's say to the 1,000th position, 1.386. Is that right? A is about 1.386. Questions on that? All right. Answer out this question. Do this whole thing on your own right now. Do this whole question on your own, please, right now. Who can tell me what the regression equation for this is going to be? That one yet? Grace, you got it? Can you give it out, please, to the 10,000th position?
Yeah, y equals 14.240.
Okay.
Times the quantity of 0.96.
Shouldn't there be something after the 10,000? Oh, 10,000 is 4 spots after the decimal. So we need this.
And the first,
Okay, what is it?
it's 14.29. 7.
6, 7.
Yeah.
Okay.
The
And then
B value would be 0.9559.
is this what we got? Yes or no? Okay. What's the second part of the question going to ask us to do? Sean, help? Yep. What do you think about people who don't show the substitution in? Would you talk to them? Sean, would you talk to them if you knew somebody wasn't showing their substitutions in? Good for you. Good for you.
Sure.
Now, what do we get as a value to the nearest 10,000th, right? What would this approximation end up being? If you want to, yes. Bless you. I'm always conflicted as to what to go through and put, because I mean it is, because then technically like everything after it, is it, and then we get into this awkwardness where, is it equal to that because you're using an approximate model? You know what I mean? Or is it approximate because you approximated way up top? I'm not smart enough to know this. Now, here's one though that we should be very good at. by the way, we've braced you for this enough, but the word problems that you're going to be doing, understand, they are like mental Novocaine. You have to persevere through them. The topics are not going to be interesting, ever. The data below shows the average growth rates of 12 weeping something trees planted in Washington, D.C. At the time of the planting, the trees were all 1 year old and were 6 feet in height. What type of model shows this? So now we've got three choices. Is this, look at the data. You've got the age and the height. Look at the data. Is this going to be linear, exponential, or logarithmic? Let's take them one by one. You don't need a calculator to figure this out. Look at the data. Is this linear? Look at the data. Is it linear? Hands up, please, and tell me yes or no, and give me the why. Like, I need to know which one and why you're saying this. We got 3, 4 of you. That should be way more than this. Look at the data. Is it linear, and what's your justification for the conclusion that you're making? What?
It's not linear
Why?
because you get a height, the heat is not growing constantly.
Even though this is a real world situation. So you're right. Trees don't sit there and go, oh, I grew a ½ inch this year, I can't grow anymore. That's not how it works. Is the data going up even by about the same amount each year? No. So it's not that. Who can tell me, is this exponential? With a yes or a no. We got one person. Look at the data. Is it exponential? Yes or no? Tammy, what would you say? I would say no. I don't think this is at all. You can tell me why this would not be exponential.
It doesn't increase that rapidly.
Yeah, doesn't exponential growth have some huge increase at the end? Does this have a huge increase at the end? No. So we're going to say it's logarithmic, and we're going to show you why. Do you remember what the log graphs look like? And the one thing that I heard a couple of you mumble, but you should be proud of your answer, don't hide it. They said, well, it looks like it would be at the inverse of the exponential. If the exponential rapidly rises at the end, I think it was you that said it rises rapidly at the end, what is the inverse of an exponential going to do then? Is it going to rapidly rise? What's the inverse of rapidly rising? Rapidly slowing. Is that what's happening? Yeah. Now here's what I need you all to do. Create a new doc right now and plug this data in. And label it accordingly so you've got the age and the height. So go in and input this data, and once you input it, I need you to do something with it. We'll go over it in a second. Now, is all this in correctly? Let's hope. Does anybody remember how you can get it to plot the data out? There are a couple people. Who remembers? Because I don't. I know that there's a way to do it. We have people walking through. Connor, you wait a minute. Let me do this. Stop. You know how to do it, Connor? All right, then ready? This is your big. Stop. Presenter. Show name, sorry. Connor, where are you on the list? Oh, right here. Fabulous. All right, so Connor, walk us through. What are we going to press?
Control dot, and then you add 5 data and statistics.
Okay, so control doc for a new page, and then 5 data and statistics. Make sure everyone's there. Now, you get, let me do this. Does everyone's screen look like a bunch of rando dots? There we go. Now, You click down here, and what are we putting along this axis? And then up here, what are we putting along this axis? Now, does that look like a logarithmic or an exponential or a linear? Which one? Should look like a logarithmic one. Now, what's the average height? So that shows it. What's the average height of the trees at 1.5 years of age? What do I need to know before I can answer that question? We need an equation. What kind of equation? We need to find a logarithmic model for this data. So go in right now and take a logarithmic regression. And yes, it may need you to scroll up and down, and boy, they make it tough to figure out which one you would pick for a logarithmic regression. I know it does. It says logarithmic regression right on it. So go in right now. Take your logarithmic regression. Really? You got to pay attention. Good. You'll go through and do it now. Go back. No, don't tell. Go back to the table. Take your logarithmic regression.
Do it right there. Do it right there.
Here, he's fine. Go in here.
I know, honestly.
That's fine. He knows. Go down to 4 for statistics. Go down to stat calculations. Now, this is where it used to be really tough on the other one. There you go. Take it from the logarithmic regression. You've got to go through, how many spots do we want to round, Grace, after the decimal? It doesn't say. So how many spots do you want to round? 100 spot. Fabulous. Go in now. Just go down. You can scroll down and take your regression. Scroll back up. Now, it tells you the format. Go up one cell, please. It tells you the format to take the regression in. You're giving this out to 2 spots after the decimal. Every one of you can fill this in. It tells you what the format is. So look at what's there and fill it into the 100th position. Fill in your regression to the 100th position. So, Anthony, tell us what that regression is going to be. Okay? Who remembers what that's called? Natural log. Is that rounded correctly? Yes or no? Yes? Great. Then once we got there, let's keep going. What would we do now to answer out this question? Grace, what would your next step be?
You substitute the 1.5 years for x.
There you go. So we're going to say y is going to be equal to, and I know it's approximate, so plus 6.11 times the natural log of 1.5. Their answers were all, well, we'll go out to the hundredths. You type that in exactly as it looks, and let's see what that's going to come out to be. And Riley, let us know what you get as an answer when you get it, please. .58, and what is that, feet? 8.58 feet. Now, does that make sense? Look at where this would fall. Does it make sense, yes or no? Okay, great. Let's do the second one. Predict the age of the height of the, predicted height of the trees, 20 years of age. So what would you go through and do, Kirsten, to get an answer for the second one?
You plug in 40.
What do you think about people who don't show the substitution in?
Right.
I wouldn't either. Do you think that it would be inappropriate to maybe ask the blank question bear to attack those people? You don't know? Maybe we'll ask that as a question. Nice question, Barrett. It'd be wonderful. Have a school board meeting. There was some random children have gone missing from the Algebra 2 Enriched test. We don't know what it was until you get a presentation. Oh, they left the question blank on the regions exam. So a mythical bear attacked them and dragged them off into the woods trying to trade it. And they go, oh, that's fine. Sorry, we didn't know. Corey, did you get an answer?
Yeah, 24.40 feet.
Now, and notice, by the way, some of you think that because there's a 0 there, you don't need to write it. It is significant. Yes, you always go to that position. Now, there's two things that we want to get. Is this prediction realistic? So, look at the data. If I go out to 20 years, is it unrealistic or realistic for the height of the tree to be 24 feet? It's realistic. Very much so. And furthermore, I mean, somebody said, well, then what's an answer that wouldn't be realistic? I don't know. Would 700 be realistic? Probably not. Look at the data. At 11 years old, it's 19 feet tall. At 20 years old, it's 700 feet tall. Does that make sense? Probably not. Now, the other question, and this is just a general, how much do you understand the English language? Who can tell me the difference between interpolate and extrapolate? We went over it once before, I know we did. Can anybody tell me the difference between an interpolation and an extrapolation? We got 1, 2. That's it? 2 people can tell me the difference between them?
What would be like in the data within it, and actually would be outside, so you have to figure out.
There you go. What is, if it's interpolate, it's in the data you're working with, so between 0 and 11. If it's extrapolate, that means you've got to go through, or extrapolate, either one. You go through and say between anything beyond 11. Like 12 would be extrapolating out the data. Now, this always comes up when somebody goes, oh, we're done for the day, right? No. No. Let's go back, please. You've noticed I give you so many questions. It's disgusting. Let's go back, please, and take a look at, I don't know. Let's do our question number, let's go to 27. Should be the top of 27. What are we going to do to start off 27? Kenneth?
You're going to multiply the x times the x is 5.
So what are you writing now?
Well, 6.
Base 6. Which is? Hands up, please, if you can tell me what your next step is going to be. Really? One person? Oh. Wow. Wow. One person can tell me. 2. It's terrible. Marissa D, what would you do from here? Absolutely right. You need to go through and exponentiate this, so that means that number to that power gives me that value. So this would be 6 squared is equal to x squared plus 5x. From here you should recognize this is going to become quadratic. What do we do now from here, Royce? So we've got 0 equals. What would we do to solve from here? Hands up, please, if you can tell me what your next step would be. Really? Woo. Wonderful. John, what's it going to factor to? No? It's not going to be 12 and 3. Who knows what the values are? What's this going to factor to? What's your next step going to be from here? Tommy? Rhymes with tractors. There you go. So we've got x plus 9 equals 0, and x minus 4 is equal to 0. So your answers are x is equal to -9 and x is equal to 4. Now you have to justify the answers that you're giving. So go back into your calculator, plug both of these into the original. Go in right now, please. Plug both of these into the original. There's more than one way that you can do this. No, I'll figure that out. Should be log base 6 of x plus 5, etc. Now, when we do it out, you've got to make sure, as you do this, as you plug that in, make sure, please, that when you do this, if you get that triangle, that doesn't mean you give up. It doesn't mean, oh, it can't be solved. Your strategy might be different. So let's do, careful, you got to select that and do the bar, and then do, what were your answers? X equals what? So x is equal to, was it -9? And what's the other one? 4. Did anybody get a triangle when they checked it? A non-real answer? Okay. Some of them, again, if you get that, here's the way to check. Go back to this answer right here. Go back, highlight this expression, hit enter, and delete the equals to. So don't do it as an equation, do it as an expression. Delete that. Now, it's still going to evaluate this expression at x equals 9. So hit enter on that. What does it equal? Does this equal 2? Yes or no? Still has a non-real, so then that's not going to work. Go back up, though, and do the same thing and put in, go select this and put in a 4 there at the end. And it should equal, if it's true, what does it equal? 2. He has complex numbers turned on, that's why. We're not going to tinker with those settings, okay? Now, what we're going to say is this. You all have a quiz next time we have class on the stuff that we've covered so far this unit. You all have a quiz on it. So, instead of going through again and doing extra credit, you're going to go through and take assignments to show that you know what you're going through and doing. Hand those back quickly, please. Hand those back quickly, please. Your homework is to make sure that you study those questions. I advise you to do this. My advice for you, go home tonight and get the questions on 21 through 19 done, pages 19 through 21. Know how to answer the questions on 19 through 21. You've got to know log to exponent conversions, etc. You've got to know your stuff. We're not trying to be punitive at all. We're just trying to make sure that you know your materials and know your questions. Excuse me.
The homework from last time. I did not understand computer.
So, when you do this, what formula?
That should have been.
Yes, that's fine.
Yeah.
You did this
How
right.
did
Here.
it by itself, though?
Because this is a numeric value.
That hurts.
It's even worse here. Take this. It's terrible. Now. Right? It's times what? Right. So this, right now, you've got to recognize this is a number value, isn't it?
Yes.
And by the way, this is not right. Your replacement is, it should be 1,000 is equal to P times E raised to the 0.05 times 10. Go through, divide this out on both sides.
Oh, see, I was dividing by P, and then I'm like, but P's on the denominator.
P's the answer.
Yeah, I was so confused on how you would get it by that. I understood you had to divide, but look, on this one, see, I was trying to divide
Same thing in
by P right
53.
there. I was trying to divide by P.
Same thing in 53.
Because I was trying to get the log by it.
Okay.
That's
This is yours, though. Yep.
I don't, yeah. Oh, yeah, I'm not kidding. I was so, that's all I had to do. I'm like, oh.
I was trying to not really need education. I know.
You got questions?